All right, this last way to do finding the equation of the line, here I'm going to give you a point, I'm going to give you a green ball, and then a relationship to another line. So it's like throwing you a purple ball, a totally different piece of information. This is the one that is the trickiest. So you may want, there's several examples. There's a lot more examples of all of these types in the book. So you've got examples galore to look through if that helps. Okay, first of all, let's look at the information I'm given. It passes through the point 3, -1. So that's like a green ball. It's not a blue. It's not the y-intercept. It's just some random point. And it's parallel to this line right here. So I'm not given the slope. I'm given something to help me get the slope because parallel, that's a slope word. But I don't have the slope yet. So remember, no matter what information you're given, the first thing you always do is find the slope. So we're going to look at the fact that it's parallel to y is equal to 4x plus 5. So I want to find m. Now if it's parallel to that line, that means that it has the same slope as that line. What is the slope of the line y equals 4x plus 5? Well, luckily that line is in slope-intercept form. It has y by itself. So since y is by itself, it's in slope-intercept form, we can get the slope just by looking at it. What is the slope of that line? The slope of that line is 4. And since I want a parallel line, I just want a slope of 4. So I actually was given the slope. It was pretty easy to get. We'll go on to examples where it's not quite as easy, but all we're looking for is that slope. Now let me just caution you about one thing. Once you get the slope off that line, throw the line away, cross it out, don't look at it again. That 5 has absolutely, completely nothing to do with what you want to do in your problem. The only thing that 5 will do is confuse you. Once you get what you need out of that line, throw it away and don't look at it again. We have what we need. We have the slope. We no longer need to look at that line, so just forget about it. Okay, now that we've got the slope, we know the slope is 4. I want to find b for my line, not that line, for my line. So b, I'm going to say, okay, y equals mx plus b. I'm going to take my point, 3, -1, put that in for x and y, take my slope that I have, which is 4, plug everybody in, so I have -1 equals 12 plus b. Subtract 12 from both sides, so I get b equals 13. So the equation of my line would be y equals 4x minus 13. Let's graph it and see how it does. So the first thing I do when I'm graphing is I plot the -13, which is clear down there. Then I come up 4 over 1, up 4 over 1, up 4 over 1. And I get this line right here. Let's see, does that pass through the point 3, -1? Let's see, go over 3, down 1. Yeah, it does. That point's on there. Is it parallel to y equals 4x plus 5? Well, y equals 4x plus 5 is pretty easy to graph. It's just right there. Yeah, and they're parallel. Okay, let's do another one. It passes through the point 9, 5, and it's parallel to x equals 2. Now remember what I said earlier. If you're dealing with horizontal and vertical lines, with vertical lines especially, graphing is usually the easiest way to solve. Just use your intuition to figure out what it is. Going through these formulas will work for horizontals, but they won't for verticals. It'll just make you frustrated. So let's look at what we've got. We know that it passes through the point 9, 5, and that it's parallel to x equals 2. Since x equals 2 is talking about slope, I'll graph that first. There's x equals 2. There's the point 9,5. It doesn't matter what I put on the graph first, but I had to do something first. Okay, so I know it passes through that blue point, and it's parallel to that green line. So it's got to be this line right here. What is the equation of that line? Well, it's vertical, so it has to be x equals. Well, what does x equal out there? Yeah, x equals 9. So my equation is x equals 9. I know that doesn't seem very watertight, but with horizontal and vertical lines, again, the best way to solve those is using your intuition. Okay, here's another way if you prefer. So let's say it passes through 9, 5, and it's parallel to x equals 2. So first I'd say I want to find m. M is undefined because it's a vertical line. So it means that my equation is x equal to a number, and the only number it could be equal to is 9 because I have the ordered pair 9, 5, so I get x equals 9. Either way works. I think graphically makes more sense, but everybody thinks in a different way, so you just pick. Okay, let's do another one. It passes through the point 3, -2, and it's perpendicular to y equals 1. Okay, again, with horizontal and vertical lines, it's sometimes easier to just kind of use your intuition. I will do it both ways, though. So if it's perpendicular to y equals 1, let's put y equals 1 on the graph. There it is. That green line is y equals 1. Now it passes through the point 3, -2, over 3, down 2. Okay, it's perpendicular to y equals 1. Well, that means it has to be this red line. What is the equation of that red line? I know that it's x equals a number. What does x equal there? X equals 3. Okay, let's do it maybe a slightly different way. I mean, they're pretty close to the same thing. But if I know that it passes through 3, -2, and it's perpendicular to y equals 1, find m. The perpendicular to a horizontal line is a vertical line, so I know I have x equals a number. The only number that x could equal is 3, because look at my ordered pair. I have 3 in the x spot, so it's x equals 3. Okay, let's do one more that is going to be a little bit closer to what the mainstream type of question is. Let's say it passes through the point -2, 1, and it's perpendicular to the line 3x minus y equals 2. Now remember, no matter what information you're given, the first thing you want to do is find the slope. Now, I know that it's perpendicular to 3x minus y equals 2, but what is the slope of that line? Can I just say it's 3? No, I've got to get that in slope-intercept form. So I have to get y by itself. So if it's perpendicular to 3x minus y equals 2, I'm solving for y. I subtract 3x. So it's perpendicular to -y equals 2 minus 3x. Have I solved for y yet? Not yet. Multiply both sides by -1. So it's perpendicular to -2 plus 3x. Now I realize I've been requesting that you write the variable first. I just want to show you that you can do it the other way and it will still work. You just have to keep track of which one's your slope and which one's your y-intercept. Your slope will be in front of your x. So my slope for this line right here is 3, because I have a 3 in front of the x. What would the perpendicular slope be? Well, if the slope of this line is a positive 3, the slope that I want would be a -1/3. Now, once I've gotten the slope out of that line, throw the line away. Don't look at it again. That 2 or -2 has absolutely nothing to do with the problem. Please don't look at that line again. Once I've got my slope, all I care about is the slope and the point that I've been given, that -2, 1. So I want to find b. I use my y equals mx plus b, plug everybody in. 1 for the y, -1/3 for my m, -2 for my x. So I get y equals 2/3 plus b, or b equals 1/3. So I have y equals -1/3 x plus 1/3, which is kind of gross, but we can graph it. Now that we know have slope-intercept form, it makes life so much easier. So I know my y-intercept is 1/3, so it's just up a little bit, and then I'll go down 1 over 3, or up 1 back 3, and there's my line. Let's see if it works. Does it go through the point -2, 1? Let's go back 2, up 1. Yes, it does. Perfect. Is it perpendicular to 3x minus y equals 2? Well, to graph that, we'll want to look at its slope-intercept form. It would have a y-intercept of -2 and a slope of 3, and those look pretty darn perpendicular to me. Never hurts to check your work. You do have an answer key, but little graphs have been provided on your homework, so you can check your work yourself.